Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Farizuddin with Zulkefli, and today I will present to you about my research proposal, which is a prototype of IoT-based noise pollution detection and notification in library using noise sensor and blink application. This research is supervised by Madam Rashidah binti Ramli. In this slide, there will be three content, which is chapter 1, chapter 2, and chapter 3. In chapter 1, we will talk to you about a background study, problem statement, research objective, research scope, and research significance. While in chapter 2, we only talk to you about the latter works regarding to this research. And finally, chapter 3, we will talk to you about the methodology for this project. First of all, background study. The Internet of Things, also known as IoT, and its applications are now crucial components of modern human lifestyle because of its low cost, high efficiency, and versatility, stated by Saha et al. In 2018. IoT devices have the advantage since they are compact and affordable that capable to gather data and send it to a server, stated by Palis and Spachos in 2021. Noise pollution is a physical form of pollution that, if it exceeds health regulations, it can have a major negative impact on people's health. This is stated by Meshkov and Naumowski in 2021. There are several causes of noise pollution in a city, including public events, building sites, and automotive traffic, stated by Palis and Spachos in 2021. For the problem statement, library was known as a place with a low sound level as it served as a place for people to study which has the sound level of below 40 decibels. However, noises in library were mostly caused by some visitors who came without any actual purpose. The noise caused slight disturbance to other visitors who intend to study comfortably. Next is research objective. This research is to develop a prototype that can measure the noise in an area and send notification to a mobile device using noise sensor, not MCU ESP8266, also known as Wi-Fi module, and blink application. This research also to evaluate the performance of prototype using functionality tests, network testing, and technology acceptance model, also known as TAM. For research scope, we have 5 main points, which is the first one, people. The community that involved in this project are librarians and students. This research focused on persons who having a hard time keeping their voice lower inside library. Second, area of project. This project is done inside UITM library. And third, software. Coding using C or C++ language in Arduino software IDE and using Blink application. And number 4, hardware. This research used noise sensor. The components used are Arduino, power supply, LCD display, not MCU ESP8266, a few wires, and any Android 10 mobile phone. And last, performance evaluation. The performance that needs to be evaluated is based on the functionality of the noise sensor, the response time alert notification sent to the user, and questionnaire of technology accepted testing. For the research significance, this research helped in reducing unnecessary noises in a library, thus reducing the workload of librarians in reminding the students to keep quiet inside the library. Next, librarians get a notification through their mobile phone if they are making noises past the acceptable limit of loudness, which is 40 decibels. And lastly, to monitor the level of noises inside the library as the research project captures noises in real time. The expected outcome for this project is to resolve the noise problem that occurred in every library and able to have alternative way to ensure all visitors inside library are able to study in comfort and keep the noises in check. This is the related works regarding my project. The first one is automation of noise detection using Internet of Things. The objective is to reduce noise pollution, same as this project. And the method used is Arduino voice recognition board, pick-to-kit, and proteins. While our project will only use Arduino and no sensor and link application. And the findings of this project is the person who speaks in an enclosed area will have his or her mail gets alert notification. And next, for the noise pollution measurement system implementation and perspective, the objective of his project is implementation of noise measurement and monitoring system, and the method was using Raspberry Pi, the model P+, built-in Wi-Fi adapter, simple microphone, and used software Django. The findings of this experiment is Raspberry Pi is relatively easy, inexpensive, and multiple copies of the device can be easily made, which can be interconnected and get a sensor network. While for the last paper, which is design and development of a low-cost IoT-based environmental pollution monitoring system, the, uh, the objective is to provide a low-cost environmental pollution monitoring system for monitoring the highly toxic gas. And the method used is they're using 80 Mega 328 microcontroller, sound sensor module, Visual Basic, and AppSheet. By these findings, the device is very compact and nifty, which makes it transportable and can be carried to any place at a little speed. Next is methodology. In this methodology, we have 6 phases, which is information gathering, planning, design and development, experiment, analysis, and lastly, documentation. For information gathering, we will start by while doing background study and to find problem statement, research objective, research scope, and research significance. The technique used will be library and online research, and the outcome will be we will get the problem statement, objective, scope, and significance for the background study, and we also will get to the literature review. For planning phase, the activity done in this phase is we will identify the project requirements of hardware and software for this prototype, and the techniques used is we will search the keywords from previous related works and add improvement components. And for the outcome, the project requirement we have on this project will use Arduino Uno, noise sensor, LCD screen, Wi-Fi module, mobile phone, and laptop for hardware, and Arduino IDE and Blink application for the software. Next is design and development. In design phase, we will design flowchart and design topology of prototype using star UML, and the outcome we will get the flowchart of prototype and the network diagram. While in the development phase, we set up a hardware used in the research, coding, and we configure Blink application. In coding, we'll use the Arduino IDE software tools, and the prototype will have the prototype will be installed we install all the hardware, and the prototype is ready for experiment phase. And for the Blink application, we configure using Blink application, and the alert through mobile phone via Blink application. This is the network diagram for this project. It started with the sound source, and it will detect by noise sensor, and the Arduino Uno, which is powered by power supply, will show the sound level of current noise on the LCD screen, and then it will send the data required through Wi-Fi module using Wi-Fi, and then it will send the data to the mobile phone which has installed Blink application, and then the data will be saved on the cloud storage, and the data also will be transmitted to the user, which is librarian. And for the flowchart, first of all, we start with power supply, and then it goes to Arduino board, and then noise sensor module. If the noise sensor detects any sound level above 40 decibels, it will send to the Wi-Fi module and alert notification using the application. If the power is still on, it will start over from the noise sensor module. And if the noise sensor detects sound is not above level 40, it shows current sound level, it will start from noise sensor module. Next is experimental phase. In this phase, prototype will be tested to control and create a scenario to verify its functionality and the objective of research achieved, and run the test at least 3 times to get average results and submit questionnaire to set the user. The technique used is functionality testing on noise sensor, network testing, and technology acceptance model. The outcome will be get the data of performance of IoT-based noise detection and notification library using noise sensor and link application to monitor sound level in library. Alright, for functionality testing, we will do a noise sensor test, which is this sensor will be used to monitor the sound level of noise in the library. From this testing, the result of sound level detected above 40 decibels will be sent to mobile phone via Blink application. So we'll be doing two type of tests, two type of experiment, which is the first one we will do a sound level of 30, and the second one we will use the sound level of above 40 decibel. If the first experiment prove the functionality testing, the first experiment will have all of the response denied because we want the noise sensor to detect the sound level above 40. Alright, next for the network testing, we will do a response time test. In this test, the experiment will be done in different distance between the prototype and the mobile phone to measure the response time of alert notification in mobile phone. We have three types. We have three experiments with different distance. The first one is 3 meters, 6 meters, and 9 meters. The sound level of each experiment will be same, which is 40 decibels, 45 decibels. And next is technology acceptance model. The table. This is a questionnaire will be sent to the selected user after we done with the experiment. And next for the analysis phase. In the analysis phase, we will analyze the result of the experiment, and the result of the experiment are collected and graph is plotted. And as the outcome, the functionality we can determine the functionality of the prototype, average response time for notification sent to mobile phone via Blink application, and technology acceptance model questionnaire result. And lastly, for documentation, final documentation phase, all the data information related to this research will be documented, and which is we compile the analysis, write conclusion, and provide recommended for the research. The technique used will be verify formatting, sentences, structures, reference, and originality of the proposal, and the outcome will be we have the project report. Okay, for conclusion, we can conclude that a prototype of IoT-based noise detection and notification in library using noise sensor and Blink application will be able to reduce the noise pollution in library by alerting the librarian on which area of the noise source. This research development is a low-cost prototype as it uses Arduino Uno as a microcontroller which is cheap and easy to use. In accordance with recent technological advancement, the implementation of Wi-Fi module in the prototype is to provide better connection to the internet and able to store data in the cloud storage. The Blink application serves as an IoT platform and medium to receive alert notification. The Blink IoT application serves as an IoT platform and medium to receive alert notification from the prototype and alert the user. By this prototype, any sound source above 40 decibels will be recorded and alert the librarian in duty to take necessary action, thus reduce the noise pollution in library. This is the reference for my research. I think that's all for me. Thank you, and if you have any questions, feel free to email to my personal email.